So tonight, there's the first presentation that I will be doing is on the constellation Serpens Cauda and Serpens Caput. And after that, kind of a open floor session for we all hear different things that are going on in astronomy and just say, hey, here's some cool things that are coming up in this year, whether they be something to do with rare planetary alignments or maybe some other thing with regards to rocket launches upcoming. There's rumor that hopefully James Webb will finally get off the ground this year and into orbit. One can hope. So just open up the floor to, conversations of that nature. Who knows, maybe we'll find something like, ooh, I want to go do that in July or whatever something is. And so any questions so far before we begin? And if you have any trouble with mics, you can also just type into the chat. I do see that as well. So don't feel the need to have to unmute. Okay. So tonight, Serpens Cauda and Serpent Caput was a constellation that was last at AFSIG sometime in 2014. And it was kind of a moment to revisit it because we never really saved any of the presentations prior to that. So it's, kind of building up a library. Can everyone see my screen okay before I do continue? Because there always is that one, where did it go? You should now be seeing an overview slide. Okay.
Yes.
Cool. So Serpens Cauda and Serpens Caput are also sometimes just jointly referred together as the constellation Serpens. They are the 23rd largest constellation in the night sky out of the 88 total modern constellations. And it is slightly larger than the constellation Perseus, which is up right now. Currently, Serpens Cauda and Serpens Caput are rising very late at night, actually more closer to dawn because they are part of the with the constellation Ophiuchus, excuse me. It has ties to like many of the Greek constellations where they kind of borrowed other things from other cultures as well. So there's some stuff in here from Babylonian and Egyptian mythology. Not really too much interesting, so I didn't go much into some of the lore. Wanted to focus mostly on some of the objects. Of note, it has the constellations taken together have two Messier objects and several open and globular clusters because they're lying close to the central bulge of the Milky Way galaxy. Because I cannot remember which one is which off the top of my head, the one farthest from Sagittarius actually has a good smattering of galaxies as well because it's far enough away from the galactic disk. But most of those galaxies are in the magnitude 11 range, which would make them very challenging to see without something larger than an 8-inch scope. Even in some of our dark sites like Tempa or at CAC, they would kind of be a struggle to see. And I typically limit myself to things that can be seen with an 8-inch telescope because that's kind of the most common form that we would get with people who have Schmidt-Cassegrains or Newtonians. People who may be using refractors, you could have some luck. It depends on the size of the refractor. So. Depending on what sky chart you're looking at there, you could see them on the chart both as a pair of constellations listed out different as the two halves, the head and the tail, or you could see them together as a single constellation referred to just as Serpents. And if you end up finding yourself over on Wikipedia, sometimes you'll see things listed. Like if you're searching for deep sky objects that you might want to look at during an observing session, sometimes you'll see objects listed out as Serpens explicitly. Other times you'll see Serpens Cauda, Serpens Caput. There's not really a good consistency in terms of how people organize these two. So if you do find yourself, internet searching for things you want to look at in the night sky, just be aware that when they say Serpens, it could be on one half of the constellation or the other because of how the constellation was drawn by the IAU back in the 1920s when they rolled out the modern constellations we know today. It represents the snake, which is held by the leader Asclepius, I butchered that name horribly, but Greek is hard. And the healer itself is represented by the constellation Ophiuchus. The lore goes that Ophiuchus first killed a snake and then was resurrected, and that snake was then resurrected by a second snake that came by. Pretty short, sweet, to the point. The snake is often used as kind of like a symbol of rebirth because of how the constellation is in the morning, comes during springtime. So it's kind of falling in that interval of the winter to spring transition. So you can kind of see a relationship there between the end of the winter and the start of the spring thaw, where everything starts coming back to life again after, whatever crazy winter that they just went through. The current asterisms for Serpens were drawn up by Eugene Delport in the 1920s, again, back during the IAU, which is the International Astronomical Union's reorganization of the constellations. Any questions so far? And by talking too quickly, I do have a tendency to do that when I'm hyped up on sugar and caffeine. Okay. So this is our good old friends at Wikipedia. They have a lot of these more parchment style star charts. This one here, noting my mouse will allow me to do it, or I can just use, I want to laser pointer. So here is the constellation of Serpens Cauda and Serpens Caput kind of trailing in here through Ophiuchus. And if you look at your map, any sky chart today, you'll see that Ophiuchus, or the coffin of Ophiuchus, takes up most of this portion here. So that's why it's kind of odd, depending on how the atlas or star chart you're looking at will draw the constellation, because sometimes they might clip Ophiuchus off enough that the Serpens actually goes underneath Ophiuchus. Sometimes they won't. It's kind of up to the artistic person drawing it, or if they wanted to obey the IAE segregation of the sky or whatnot. I wasn't quite sure exactly where the bull here was fitting in, considering Taurus is nowhere near this portion of the sky. And down here we have Sagittarius, Boötes over here in the top right, and Hercules up here top center, to kind of give an idea. If you're not familiar with where Ophiuchus is in the night sky, but you might recognize some of the other constellations, to give you kind of an idea of where it is. Serpens is a fairly hard constellation to see, just because the stars in it are about magnitude 3 and lower. So you won't necessarily see it within the Tucson light dome. At a dark sky site, you might, which, even then, you're getting so close to the core of the Milky Way, there's just going to be so much stuff there, you might still not even see it at all. As I kind of hinted, it's visible best in Tucson from April to late September, which is where it's kind of rising early enough in the night that you're not, sitting up till 2 in the morning just to see something peek over the Rincon Mountains and so on. If you're looking south, which is typically where you'll find it, it's above Sagittarius and Scorpius, and I do recognize that I have a typo in this slide. I apologize. For those who might be more, go to telescope limited or use finder wheels or whatever, setting circles, just because they like the old school style. They typically range from about the right ascension, which is part of the coordinate system that's commonly used to locate objects in the night sky, from the 16-hour to 19.5-hour limits, and with a declination range of +20 to -15, so easily observable and pretty far off from the ground, since the Tucson visibility limit is -58 degrees in declination. So it'll be kind of up there in the sky. You'll have to tilt your head to see it. Kind of another star chart showing where things are. Again, this is a slightly different rendition, so you can kind of see what I mean by when people draw the constellation differently. Up here we have Serpens, Cauda, which is I think the head. My Latin is terrible. And then it gets cut off here by Ophiuchus, and then continues back on into the tail of the snake. So can be a tricky one when you're just like, but this one is in this, and you'll sometimes see objects in Western charts like, but it says this is in Serpens, but this one's like, oh no, it's in Ophiuchus. So just be aware of that when you're finding stuff. Another comparison star chart from our good friends at Sky and Telescope, kind of showing that same division of having two separate constellations cutting off by the bottom of Ophiuchus. Whereas this is head. I forget how Ophiuchus is oriented. It's like the top of the coffin, which you see here where my red pointer is his head or not. And again, so here, if you're familiar with the teapot asterism of Sagittarius, kind of gives you another reference of where they are in the sky. So this is an abbreviated list of some of the things you might want to look at within Sagittarius. We'll go through a couple of them, most notably the Messier objects, because they're easily one of the most pretty things to look at in the night sky. You can see we do have a smattering of stars, and most of the Bayer designated stars are above magnitude 3, are dimmer than magnitude 3. So you will have to focus to see some of them. Make sure your eyes are properly dark adjusted. I forget where's my notes. They're blocked by my Zoom panel. So the Serpens. So this panel on the left is for Serpens Caput, which is the head of the snake, which if we go back to this slide is over here. So this is the left slide represents Serpens Caput, which is outside of the Milky Way bounds, which is why we are seeing here in this left chart a lot of smattering of galaxies in the NGC catalog that we might look at. And over here with Serpens Cauda, which is closer towards the Milky Way galaxy, which is where we're getting all these open and globular clusters. And why this one actually has no galaxies in it, because it's so close to the plane of the Milky Way, you wouldn't be able to see anything. So Unu Kauhai is the brightest star in the combined Serpent constellation. It is about 82 light years from Earth, and it has a magnitude of 2.8. It's located in the head of the snake, well, in the asterism of the head of the snake. And it has a luminosity that's about 70 times that of our sun, so it's 70 times brighter than the sun, and about 5 times more massive. And this should be the head of the snake. I'm reusing slides from my last presentation on Aries, so I did apparently miss some things. It is classified as a K2 spectral giant, so it is more orangey than the sun. The sun is a G class dwarf. So this star is, off the main sequence because it is a giant, but it's very orangey in appearance. Not quite sure if we would be able to see color with this particular star through our telescopes. You could potentially with a large enough, maybe something like a 10-inch. I would believe someone with more experience, feel free to correct me if they've actually observed this star before. It is also a double star, so the companion star is almost magnitude 12. And the separation between the primary star, which is the one we're talking about up above, and the companion is about 1 arc minute, or a little bit more than double the size of the moon, which is quite a large amount of separation for that we normally, when we think about double stars, when we're looking at them through eyepieces, we're used to seeing them much, much closer than that. So kind of a very large separation between the primary and secondary components. This is, on the left is a star chart kind of showing where Umukuhai, I've totally butchered that again, is within the constellation itself, as shown by the crosshairs. It's just kind of hanging out in the middle of the body of the snake. and and then again, Hertzsprung-Russell diagram showing where the star lies. So as I kind of said, it is off the main sequence and up here within the giant category. Our sun sits, I think, right about here on the within the 8-year diagram. So giving you kind of an idea, it is a very large, cool star. The second star we'll talk about, and the last star, is Delta Serpentis, which I chose notably because it's actually a star system comprising 4 stellar components. The total apparent magnitude of the system is about 3.8, with the primary component having an apparent magnitude of 4.25. So all 4 stars in this system are combining to give a apparent magnitude that's brighter than what the primary component of the star is. Normally in multi-star systems, when we look at them, they're actually dominated by the primary or sometimes the secondary component within the star systems, which was kind of unusual to me to actually see that. The system is roughly 230 light years away, and the primary component is about 24 times more luminous than the sun, but well, still within the range of mass range for our sun. So this could potentially be a planet that has not planet, excuse me, a star system that has multiple exoplanets around it. I wasn't really able to see anything, at least the time that we did put this presentation together, of any discoveries of exoplanets within this system. But given how prevalent they are, and an F-type is certainly a very stable star, except it's a subgiant, but who knows? And the primary star is also in addition to being a subgiant, is a Delta Scuti type variable star, which I'm not quite sure of the characteristics of that. I kind of ran out of time in assembling this. So if Doug, I know you do a bit of variable star observing yourself. I don't know if you want to chime in with any facts about Delta Scuti type variables, if you know any off the top of your head.
Not. I do mostly Myra.
Anyone else have maybe had any experience with Delta Scuti type variables that they want to chime in with? Or have any knowledge about them? Say, hey, here's what these things look like. Here's what their differences are. Dennis, I can see your mic activating, but I cannot hear you. So, again, a star chart kind of showing where Delta Scuti is. This also is within the head of the Serpent. It's kind of shown here. So our first deep sky object for the night is the variable star Messier 05. I'm a huge fan of globulars just because they're very pretty objects to go look at, both visually and photographically. You point it, you get it, you don't have to fiddle much with it. You can clearly see something really cool there in your eyepiece. So always a good thing to impress yourself with, because you're not trying to fuzz out faint details you might have within a galaxy or a nebula where you're just like, I'm not quite sure I can see this faint fuzzy blob. Instead with globulars, if your eyepiece is typically, you say, this is a faint fuzzy blob of stars and I can see most of the stars. So there is like a lot of the globular clusters that we can see from with Earth, which mostly reside towards the galactic core. It's about 25,000 light years away. And it has an apparent magnitude of about 5.7, which in theory puts this as a globular cluster that you could see without any visual aids such as binoculars. It's a small size. Its size officially puts it at about 23 arc minutes, but from experience, this central bulge here is probably closer to about 12 to 14 arc minutes in diameter, which, for reference, for those who aren't familiar, that would put this as about 1/4 the size of our moon, because our moon is about 30 arc minutes in diameter. And overall, the the cluster has the mass of about 850,000 suns. So this here kind of gives you an idea of what the globular cluster would look like through an eyepiece. Again, this is a picture, so you won't necessarily see this level of detail, but this is a simulation of an 8-inch Schmidt Cassegrain using a 20mm eyepiece. So, and the eyepiece for me has a, I think a 50 to my 20mm has a 68-degree field of view. Give me 1 second. Got Zoom flashing at me. 1 second. Sorry about that. Yeah, my keyboard. Come back. This is a star chart comparison, kind of to show where the constellation, where the globular cluster lies within the constellations. This is also located in the head, kind of actually off here between Virgo and Libra, kind of located in that center void between them. Excuse me. The next object for the night is Messier 16, which is both an emission nebula and an open cluster. Its distance is about 6,000 light years away, give or take. It is just below what we could see with naked eye. It's coming in at magnitude 6, with an apparent size of about 7 arc minutes. So it is a relatively small nebula and open cluster. You would need to see this with a telescope. This is a poor image showing what you could expect. You can kind of see here are the pillars of creation that you typically see when in images of the Eagle Nebula. I know it's kind of hard to see this with all the yellowing done by this particular simulation. Again, this is done with an 8-inch Schmidt Cassegrain using a 20mm eyepiece. So you can fit this, and for the most part, when you look at this visually, you won't be seeing any of this faint filamentary gas here that's on this outer rim. You will definitely be able to see the pillars of creation, and if you have really good skies, you'll probably be able to see this pillar over here, and some faint filamentary dust kind of here closer towards the core where the rest of the open cluster lies. And, so we are looking kind of off here, closer between Scutum and Serpens, for where we might find this. It's actually just off of this Hippus Sagittarius with a lot of the other open clusters. I think here's this. Forget which one this is. I photographed this one. I can't remember whether it is off the top of my head because I'm not seeing that.
Green one's M20.
Yeah, this is M20 and M8 right here. And this is like M22, I think, or M23. No, 21, 8, and 20. And the last object is another globular cluster, which is NGC 6539. This is also about 24,000 light years away. It comes in at a magnitude 9 with an apparent diameter of about 8 arc minutes, and fairly small in the globular cluster set, coming in at about 500,000 solar masses. It was cataloged in 1856 by the Danish astronomer Theodor Boersen, which was if I call out because usually when you look at the NGC catalog, they typically were logged by either William or Carol Herschel, who were some in the late 1700s, who were some of the original catalogers for the NGC catalog. So finishing up with an eyepiece simulation. This is an 8-inch Schmidt Cassegrain with a 10mm eyepiece. So, fairly small globular. You will probably be able to see a little bit of the core. May struggle a little bit seeing a lot of the definition, but it should be there. And so the star chart would put it somewhere right about here. The Sky and Telescope Search Charts don't always put everything in here, but this is kind of where you would expect to see. Sorry, right about here is where you would expect to see the globular cluster, so well north of M16. And for those of you who these are some of the references that I commonly use when assembling some of these presentations. They're fairly good at getting a lot of the charts and the maps and stuff figured out. So that's it for the constellation of the month. Any questions or comments?
I sent you 2 things in the chat room.
Yeah, I do see that, Doug. So going back to the star, do
Alpha.
this. Need 1 second.
Oh. Okay.
So what Doug had sent me in the chat was talking about here with Unu Kalhai, that this star, you should be able to see some color with it, even with a 6-inch or larger telescope. So you might be able to see some of the orange hue from the star. And the other item he mentioned is
and
that
my typing is dark, so I typed wrong. That's delta static.
Yeah,
the
that
dwarf Cepheus.
So they're a variation of Cepheid variables then?
Yeah. Fast period, less than 10 hours, and magnitude range greater than 0.3, but less than a full magnitude in terms of their variation.
Okay, so that does make sense. I would put this as probably what, a magnitude 3 to a magnitude 4, depending on where it is in its peak.
Right.
Okay. Any comments or questions before we wrap up the constellation of the month?
Yeah, I've got a question about that double star that are an arc minute apart. Are there other stars in that view where is it easy to tell which 2 are the double, or which is the second star, or are there some other stars still in the view also?
Oh, sorry. So, given the dimness of the companion star, it's a magnitude 12, you would probably be very pressed to find it because there would be so many other stars that would outshine it in the field of view.
Yeah, I forgot about the brightness.
But that is a good question. You probably wouldn't even know. I think the only reason we know it's a double star is from professional telescopes who were performing astrometry observations on the star, or something like Gaia, which managed to clue us in that it was a double star. But very unobvious double.
Connor, I have a comment, a point of possible confusion. On that same screen there, you mentioned that the angular separation is approximately 1 arc minute. You went on to describe that as being twice the size of the moon. I don't believe that's true.
No,
Oh, sorry.
The moon isn't 30 arc seconds.
Thank you for that correction.
No, the moon is 30-something arc minutes.
Yeah. Thank you for that correction. I did jump the gun there with my measurements.
Twice,
very-
twice the size of the moon, it'd be one arc degree. That would be one heck of a double star.
Yeah.
1 arc minute is a pretty wide separation for most double stars, though.
Are there any? Not even aware of any that are that wide apart.
Bizarre. Up in Ursa
Perhaps.
Major is pretty wide. You can actually separate that with your naked eye if you've got good eyes.
Would probably have to be very, very close by, right?
Now, hey, Connor, do you know if this is an actual double star where they're gravitationally bound or whether it's just a visual double?
I don't recall the wording of the reference I used. I think it just listed as a double star, but didn't make a distinction between a visual double or a true binary.
Okay.
It was an excellent question, though. Okay. So, moving on from the constellation, then, what all are you guys looking forward to this year in space?
Yeah. I'm going to finish my hydrogen alpha observing program and get my certificate and pin, and I'll get my advanced observer award too.
That's a pretty tedious accomplishment to get.
Hydrogen alpha only takes about 2 months, but you have to have the equipment to do it. And the hydrogen alpha equipment is not cheap.
Is this solar observations or?
Yes, observing the sun in hydrogen alpha. But that'll be my, that'll qualify me for the Advanced Observer Award, which is the next step above Master.
So a couple of things which I had to go and re-Google to remind myself about that we do have coming up here in February is the planned landing of the Perseverance rover on Mars. That's coming up.
Correct, yes.
So that's going to be a fun thing to tune into on all the news channels.
It's going to be another one of those ones where they're going to be scared for a few minutes until the landing thing works. They're doing it the same way they did the last one. They're going to drop it down on cables and all of that.
Skytrain.
Yeah. And being, 6 minutes away, like travel time, they obviously have no control. It's all automated. So they just have to cross their fingers and hope for the best.
Yep.
It worked last time.
Got a helicopter also.
Yeah, that's gonna.
That's right. Got a little. That's right. It's got a little remote drone vehicle to fly around. That'll be kind of cool. That should give some very interesting images.
We also
I wonder
have.
how much battery life that little thing has, though.
I think it's like 90 minutes of battery, but I can't remember if it could be if it was a solar rechargeable as well. It's mostly
Powerful.
it was mostly a proof of concept. Can we do this sort of thing? So if it works, it works. If it doesn't, oh well, doesn't matter much. It wasn't part of the primary science mission anyway. Cool if it does.
There's a lot of chatter on the forums right now about the 2024
Clips.
Yeah.
eclipse. A lot of chatter going on about, if you want to see it, start making your plans immediately.
Oh yeah.
Evidently, some tours and hotels are already selling out.
Oh, yeah, definitely.
I saw one fellow said he and his wife were planning on doing a road trip down there this summer just to scout the area out and figure out where they want to set up.
We're going to try to go to Mazatlan to watch it. That's where the longest duration will be, over 4 minutes.
Mm.
They're kind of restricted to weight taking a plane, though, unfortunately.
I have family in Texas, so I can just like, hey, we're
There
gonna
you go.
bunk at your house, and drive out, and come back same day.
There you go.
Yeah, I have family in Texas and in Indiana. So I got family all along the thing.
Well, you could
so
drive the whole path.
yeah.
Make sure you go to that spot. Where is it? Ohio, wherever, where
Oh yeah, where the last
the
one
last
through.
one went through too.
Yeah, the
So-
farmer's cornfield.
So also on the
Yeah,
subject
well,
of Mars, there are two
People
other
who live in
missions.
that.
Go ahead, Doug.
Go ahead.
So
People who live in that town should be out buying Powerball tickets and things. They're the luckiest people around. Have 2 eclipse paths cross through their town
within their lifetime.
within the same lifetime, within a decade of each other. What are the odds? Buy a Powerball ticket.
So on the subject of Mars, there are actually two other missions as well. Another one that's slated to arrive on February 9th is from the United Arab Emirates, and it's actually their first mission to the Red Planet. They're doing an orbital. They're not actually going, they're not doing a landing mission. They're just doing an orbital satellite. And China was also having their first Mars mission as well, which they haven't really said much about, but everyone expects it to arrive mid-February, given the hush-hush. We'll say nothing about anything at all. Chinese government tends to be. So but
Do you
they
know
are
if it's an
they
orbital or if they're actually going by land something.
they are doing a lander.
Oh,
So they, according to this, they're doing. It's going to enter orbit, spend a couple of months preparing, and then it's going to do a descent. So it will be a lander of some type, landing in the Utopia Planitia region, wherever that is on Mars. If Marsographers in the meeting to kind of give you some idea.
The lady who was in the last meeting was talking about Planitia, Europe. Yeah, he was talking about that same area.
the book in there, yeah.
Yeah.
So assuming that their probe doesn't crash like every other planet, like every other probe except NASA probes has, they'd be the second country to have a successful landing on Mars. So props to them if they manage to stick the landing.
Sticking landings on Mars is not easy.
Well, you got to give them credit back when they were in the Soviet Union for getting some of the first images of Venus, right?
Yeah, they own. I gave that talk on Venus.
Yeah.
They own Venus. Venus is theirs. But for some reason, they couldn't stick Mars.
They didn't really
Too cold.
try that many times either, though, did they?
Oh, they did. They tried a lot. They
To
failed.
land?
I
Oh,
think there's
really?
been
I
like a
don't
total
remember.
of like 43 probes that have been sent to Mars, and only like 7 have actually made a successful landing. Most, and almost all, and
Not
all of them are from
43,
NASA.
Not all 43 were landers, but Russia tried a lot of landers on Mars, and they just kept failing. And when we started hitting Mars, they kind of gave up and switched. They said, well, we can't do Mars, but we can do Venus. So
And assuming there are no more delays in the schedule, on Halloween, we'd be looking forward to the launch of the James Webb Space Telescope. And about 14 days later, it deploying if the horrible contraption that sun shield and mechanism is actually manages to successfully deploy. Almost going to be as nerve-wracking to listen to updates on James Webb as it is going to be able to listen to updates of Perseverance as it goes through its 7 minutes of terror. So now it's 7 days of terror as you listen to see like, hey, the sun shield didn't fully deploy. We lost the mission.
That's October?
What I have, unless there's a delay, which, being the way this year has been so far, is kind of a giant maybe there will be. The current launch date is slated for Halloween 2021.
Oh boy, that figures. Launch it on Halloween. I don't know.
Yeah. But, considering how many times like we're launching in the next 6 months, James Webb has kind of been for the last 4 years. It's anyone's guess if this date will actually stick.
I'm surprised NASA would even think about launching it on Halloween. They're very superstitious about certain dates.
They're not going to get much of an audience that evening, are they? if it's in the nighttime, at least. They usually like the audience publicity and the viewership helps their overall ratings and budgets.
Some other things coming up from NASA as well. They're going to have their asteroid redirection mission launch in July. With an estimated destination reaching their destination asteroid in 2022. And this is the one that's going to fire metal slugs into the asteroid to see how much it adjusts the asteroid's course over, the years and years and years that things take to go around the sun.
Oh, is that to rescue us from getting bombarded?
Yes. Trying to develop a
let's see here.
Anti-asteroid system.
And then we will be also having NASA's Lucy probe launch. We don't have a date on this particular article, but it'll spend a decade visiting 7 different asteroids in the asteroid belt. So that'll be something to look forward to. And then to wrap up science missions, there is NASA's launching a new X-ray space telescope as well in October.
Okay.
The Polarimetry Explorer.
The same month as the Webb?
Yeah.
Wow, that's a busy month.
Looks like Jim gave up trying to talk and kicked out. I think he was trying to say something, but he couldn't get his mic working.
Jim Knoll? Or someone else?
No, I didn't catch the last name. He was in the group here. You could see his picture, but he was trying to talk. You could see his mouth moving, and he was futzing with his microphone, but he obviously couldn't get it to work.
And Steve was there too.
Yeah, Steve kicked out on us as well. He grew a beard.
The pandemic beards.
I was going to compliment him on his beard, but he kicked out. Didn't get the chance.
It's like my husband shaved his beard off, when the barbershops were closed. And I haven't been cutting my hair. Some people have been cutting their hair.
It does look longer. You're right.
Yeah, it's like hair.
I grew my beard too. What the heck?
Is there anything else anyone's
Only
looking
my
for?
cat, and you guys have to look at it anyway.
Well, I'm looking forward to being able to have star parties.
Yeah, we all are.
And I've actually had a couple in my own neighborhood, you know, because I hadn't had my telescope out since January, the last star party I went to, and so in August I got it out and was showing a lot of the neighbors some of the you know, showing them Mars and Venus and stuff, and then one of the neighbors had an app where you could see when the space station was coming through, and so we got to see that go over, you know, in a couple of seconds, and then for the conjunction I got the telescope out again, and so then we had a bunch of people come out and got to see it. That was cool.
Yeah, the conjunction was great, wasn't it?
Oh, that was awesome.
But there wasn't much time between the time you could set the telescope up and the time that it sat. You know, the time that Venus would set. It was only like an hour.
Mm-hmm.
And the place where I could see it, there were trees in the way. You know.
I thought Bernie was talking about
still,
the Saturn-Jupiter conjunction, which happened after the last meeting.
Yeah.
Yeah.
Speaking of that, Bernie, I know you were working on an imaging project with the Saturn-Jupiter conjunction. How did that turn out for you?
Imaging project.
You were trying to
Well, we
do like getting an image every night as they approach closer and closer together.
Oh, actually, I do. I missed it one night where it got clouded out, but I did. I just haven't. I haven't put them into a collage yet. I guess that would be a good thing to try doing, wouldn't it?
Mm-hmm.
I got a set of images. I got 3 nights of images.
I think I was close to 10 or 11, if I remember right. Just that one night where we had solid overcast.
I got lucky. I got an airplane flying right between Jupiter and Saturn, or almost right between Jupiter and Saturn. Right.
So remember when the comet went by, Jim asked everybody to send in pictures, and then
I sent mine in.
So are we going to get pictures of the conjunction?
I don't know. I sent all my pictures in. I don't know if anyone's gonna do anything with them.
I was really upset about that comment. I had terrible weather every time I wanted to go and look at it. I missed every night. Every night I would go up and it's just clouds. And then when it finally got clear enough, the comet was basically gone.
Yeah. I got to see the comet one night. I tried like several nights in a row, and I had my binoculars.
So Connor, can I share your screen?
Yeah, let me make you a presenter real quick. Yeah, you should be able to present now.
Okay. Yeah. There it is. Okay. Everybody see it?
Not yet.
No.
Still coming through.
Not yet.
Remember, your internet has that weird like 7-second lag.
There it is. Yeah. Got it?
Getting there. Yay.
Hey.
Oh, wow.
Caught it right just as the plane was going through.
Different.
I got a better one.
Yeah, you can see 4 moons on Jupiter.
Yeah. That's that. I just got lucky with the plane going right through. Let me get one of my other ones up here. Where's my best one? That's a little dim. Yeah. Okay.
So that was just an accident that you got that plane in there?
Yeah, it just happens to be there's a regularly scheduled flight at that time every night. And it's not landing at Tucson International. It's flying over. So I think it's going from Phoenix down to Mexico, and it just passes right through that part of the sky at that time.
I wonder what the passengers were able to see.
Oh, they weren't able to see. You couldn't see with the naked eye.
See Jupiter.
Yeah. but I doubt they were even looking.
Yeah.
The pilots probably were.
I don't know.
Connor, if you would allow me to share the screen, I'll show you
sure.
one of my images.
Co-host. You should be good now.
Okay, yeah, I got it. Let's see, which one do probably this one. Okay.
Yep.
So you can see here, I don't know, can you see my mouse?
Yeah.
Yeah.
So you can see the 4 Galilean moons. This is a background star.
Oh.
And the interesting thing was, when it first came up, I thought, well, wait a minute, am I seeing 5 moons of Jupiter here?
Yeah.
You watched
But
it.
no, it was a background star. And unfortunately, when I took this image, it was only like 5 minutes after Ganymede, which is the moon here, had eclipsed it.
That would have been cool.
Wow.
So Ganymede had actually covered it up and then had progressed on. And had I known that that was going to happen, I definitely would have done a video of it.
Yeah,
But
that would have been cool.
I didn't find out about it until unfortunately the day after, when somebody up in Minnesota, because I posted this on a Minnesota forum as well, came back to me and said, "Oh, by the way, that had just eclipsed it."
Mm-hmm.
They weren't able to see it there in Minnesota, but he said you could have gotten it there in Tucson.
Wow.
And in case you hadn't noticed it, here's
Titan.
Titan as well. I don't think any of the other moons are showing.
Now we just gotta wait
Also,
30 years to see it again.
did anybody see the triple conjunction last Sunday night?
No,
Triple conjunction. What and what?
Okay.
it
Here's the
was
triple
Mercury,
conjunction.
Jupiter, and Saturn.
Okay, here's the triple
Wow.
conjunction. That was last Sunday night. Jupiter, obviously, Mercury, and very faintly, you can just make out Saturn. It was you could not see it visually. You could see I could see Jupiter and Mercury visually, but not Saturn. The photograph pulled it in, and I was happy to see that when I got home and looked through them, because I couldn't spot it visually. This was done with just a simple little Instamatic camera on a tripod. I went up to Gates Pass to do this. And
I was stuck by trees. Couldn't see it at all.
yeah, I would have been too, but I knew up at the pass there I would have had a good view. So I made the drive. Also, look how far Jupiter and Saturn had spread already in just the 1 month since the conjunction. I was very surprised at that.
Yeah, it seems like it took them longer to get that close together. I mean,
Well, they were moving in the same direction, remember?
yeah.
But the same is true now. They're moving in the same direction. You're right. It does seem like they're moving apart faster.
I think that's because of our proper motion is skewing that perception.
Yes, it is.
Very possible.
The Earth is moving very fast, and
Like,
But they're so much further out there. Is it really going to make that much of an angular difference? Maybe. Somebody with mathematical skills can figure that out for us.
Well, thanks for sharing, Bree. Anything else that people are looking forward to this year? I kind of gave some of my highlights. But I know some people pay attention more to the planetary happenings in our little neck of the universe than I do. So, anything fancy with Mercury or Saturn? Not Saturn, Mercury or Venus coming up this year that we know of?
Not that I'm aware of.
Right. All right. Any other topics we want to discuss? I mean, if not, I think that other Star Party meeting is still going. People want to drop off and go see that.
Yeah, it was something like 3 hours, wasn't it?
Yeah, it's from 6 to 10.
It's 10.
Yeah.
Good Lord. Where did I see that?
Just pulled it up. It's from 6 to 10. So I didn't even know it was long. I just saw that it was there, and then I had 3 messages like, "Hey, AFSIG still going on tonight?" I'm like, "Yeah."
Yeah. Yeah, I know. I saw that and I thought, well, don't go telling me about a meeting at the last minute and expect me to change everything. And I had another one. I had another Zoom meeting I was supposed to be at too. That always conflicts with this one every month. It's like, hmm.
Oh,
So I'll be doing my presentation at the February general meeting on the Astronomical League, their new programs and stuff like that. They've got a number of new observing programs that they've added to the list.
Cool.
And yeah, and a lot of them that didn't have imaging, now they're allowing imaging on just about every program. So you don't have to draw sketches anymore. You can do imaging.
Constellations. I'm sure you have to sketch constellations.
I'm not even, I don't even know whether imaging is allowed there or not. I have to look at it again.
How did you do an image of a constellation?
With just a regular camera, just go out and shoot it. Most constellations will fit within the field of view of a regular 35mm camera.
Yeah, but they won't show up very well.
they will.
10-second exposure. Yeah, they will. You actually, I've taken constellation images.
I have a couple myself.
Yeah, put your camera on a tripod and just shoot it for 20 seconds or something.
Yeah. As long as if you have a high enough ISO camera, point it at the sky for about 20 seconds on a stationary tripod, and you won't have star trails. As long as the lens is underneath 35 millimeters. And if you can keep it, if you can take a 20-second exposure, you can see most of the constellation. You can actually see when the Milky Way is up. You can actually use that to see most of the a good portion of the galactic disk as well. Just a 20-second exposure. Yeah.
Hello.
Hey. Hey, Vince.
How's it going?
All right.
Good.
Hold it up. So, for instance, K, when I actually pull my browser up and can.
Okay, Kay, so for your information, the Constellation program does not allow imaging. Oh, what a disappointment. That's one of the few programs that they don't.
Well, I couldn't try taking a picture of Camelopardalis anyway. It would just be a blank sky.
Okay.
You know, it's really, my eyesight isn't very good. And so it's like, I'm looking and thinking, gosh, I think there could be a star there.
Do the best you can, Kay.
Yeah. Oh, I do.
Drag over here. So, okay, this
All
was a
right. So
picture.
let's.
This is a composite picture I took.
Uh-huh.
The Milky Way here is a 30-second
Oh,
exposure.
Wow, that's
okay. Well, I have a camera that's not my phone, you know, a digital camera. I don't know. I'd have to try and figure out if I could.
Is that Tucson?
Yeah. The background was shot over at Tempa, and then I took a foreground picture. This is actually off of Campbell and Skyline.
Oh, okay.
Nice picture.
Yeah.
And then this was taken
Wow.
almost 2 years ago. So this is where Jupiter was,
Yeah.
September 2019. So we can see how much it's moved since then. Because
What is that Jupiter up
yeah,
there?
yeah, the bright star in the center of the field
That's
is Jupiter.
Okay.
And then
Nice picture.
this was kind of a multi shot I did showing a zoom up of different areas of the sky. So this was, the background was done at, what are my notes? A 24 millimeter lens. The center panel here was done with 85 millimeters, and the two Trifid and Lagoon Nebula were done at using my C8. So you can definitely get a fairly large field of view on a 24 millimeter lens that'll get you almost every constellation. Because this is, you have Sagittarius over here, a little bit of Scorpius right here, so you can definitely grab most constellations with a 24 millimeter lens. Gotta know where they are in the sky first, and then kind of sort through the images after the fact, because sometimes you'll be like, I don't see anything here, and then you're just like, oh, there's everything.
So like if you were to do a 10-second, exposure on a like here in the city, then would it show stars that you have trouble seeing with your eyes?
Oh yeah.
Yes, you'll if you're shooting the Milky Way bulge, you won't see anything quite like what I was showing, because that's out at Tempa where there's not as nearly as much light pollution to contend with. Where's my other picture? I'm gonna go albums.
You just go out and try it, Kay. Just experiment.
Well, it's been years since I've had a 35 millimeter camera.
Okay.
You mean like with film?
No. Just a standard digital camera.
Oh, okay. Well, I've got one.
Not using your phone, although phone cameras work pretty well too, actually.
Where's my other picture? There was one other picture I wanted to show in a similar vein. I might have to go back. I know it's in here somewhere. Nope.
I'm just checking on the global star party here. I got it running on another screen. They've got a whopping 20 people watching.
Okay.
And this was another picture I did. This is almost 2 years before that last picture I showed of the Milky Way, so you can see how much my photography skills have improved since then, because you can see there's just so much yellow here. Definitely got better at my image processing. This is also too, so this was taken over off of, for if you're driving towards Tempa on through Gates Pass and you're on Speedway, there's on Speedway and Greasewood, there's a pull-out on like the left-hand side if you're going towards Gate Pass where there's a good hill. So this view of Tucson, which is kind of hard to see here, was taken from there. And then I think I did the Milky Way image from CAC. Actually, I'm pretty sure it was from CAC because I remember Paul Walker, I think his name is. I forget. I'm terrible at names. Pointing out like, oh yeah, here's all these things, and then later, once he had given me enough reference points, I came in and annotated the whole image with with all the Messier objects in the image. So that was a fun little project I did.
Yeah.
took me like 3 months to get all the Messier pictures. Really trying to get it done before they all went down, and managed to do that because that was all done in May, and then monsoon season hit, and so I'm sitting there in September and October. Please don't let there be any cloudy skies, and squeeze it all in.
Oh, the skies are nice and clear right now.
Well,
Bernie,
this is a good time of year.
Bernie, you'll be happy. I finally broke down and bought a guide camera.
Oh, good. What'd you get?
The ASM 1200 from ZWO. Gotta just.
Now, when you say a guide camera, that's going to send the auto guide commands to your clock drive? Very good.
Yeah, bought it. After the Grand Canyon Star Party last year, I bought an off-axis guider from a member in the club who was moving to Spain. I'm like, I'll take it off your hands for $120. So got an off-axis guider and just didn't buy a guide camera yet. With 2020 the way it was, I didn't get out much observing anyway. So.
Have you ever used an off-axis guider?
Nope, I got a lot of learning to do.
Yeah, you do. I'm not particularly fond of them. In fact, I don't ever use mine. I got away from that, and I mount a little 3.5-inch Moxitov separate, and that's my guide scope. I can't stand the little off-axis guider.
Yeah, well, I'll see what I can do with it before I go out and spend another $200 on a good guide scope pair to go with it.
Okay, good luck to you. I had a lot of problems with mine because the little cutout mirror that, does the off-axis thing is only like it's less than a 1/2 inch in size. It's very small. And the biggest problem I had using it was, one, because it's such a small mirror, when you try to put a illuminated reticle eyepiece or something on a guide star, you got a really crappy image of the guide star because you basically got a 1/4 inch telescope all of a sudden, and so your resolution sucks. So the image is really bad. And secondly, if you're looking at a field, say you want to take a photograph of a galaxy or something like that, where it's not crowded with stars, you may not have a guide star that the off-axis guider will see.
Yeah.
That's the problem. That's the other problem I had is you got to find in a guide star.
Also put
I just
weight on your focuser.
Yeah. So I just said, I'm going to go with a guide scope. So I have a separate guide scope that I mount in rings, and I use that.
I'll probably be moving to a guide scope eventually, but use what you have, see if it works, see how much you hate it.
If you are successful with your off-axis guider, let me know, because I have an off-axis guider and I just don't use it.
How long ago were you using your off-axis guider?
It's wasteful for me not to use it if I can.
Because the pixel density on guide cameras has gone up a lot. So depending on when you first bought it, the guide camera you were using at the time may now.
I don't have a guide camera. I used to do my guiding visually. That's going to change in the future, but I did my guiding visually. So I would look through an eyepiece at that little 1/2 inch mirror thing, and that was very difficult. Okay, and it might work a lot better with an auto guider, and especially if you've got the good resolution, pixel thing.
The one
it
thing
might
that
work very well. I don't know. I would be really interested in knowing how that works.
the one thing you do see consistently with off-axis guiding is that there can be a struggle to find an actual guide star even with the guide camera.
Yeah, that was I mean, I got over the problem with looking at the really bad image of a star through the eyepiece. I got around that. I was able to take photographs with it. Yeah, but the biggest problem I had was finding an off-axis, finding a guide star that was bright enough for me to guide on. Sometimes what would end up happening is then the object I was trying to take a picture of would not be dead center. It would be off to one side because I had to move things around in order to find a guide star. so I wouldn't get the perfect image that I was trying to get. So the nice thing about using the guide scope is I can move that guide scope, you know, it's in rings, so I can move it. I can point it anywhere I want. It doesn't have to be pointed at the same target as the main scope is pointed at. I just need to find a star with it anywhere. So anyway, I'd be really interested to see how you do, because I had moderate, I wasn't real comfortable using mine.
Yeah, we'll see. I probably won't get any results with it till like at least March with the way things are going between
No
work
hurry.
and school. So.
We're astronomers. There's no rush in anything we do. The stars are not going anywhere.
Unless the thing you want to take is in a setting position, you got to wait another 8 months to see the dang thing again. I really want to at
Now
least
you can
try
always
to get
pull
it for working for when Virgo is in a good position, because I want to do a piggyback. My plan is to use the off-axis guider and then piggyback my camera on my telescope, and then use my 300 millimeter lens to do a wide-angle field of the whole Virgo cluster.
Well, that's a good
Because
idea.
I can do right now about 2-minute exposures on my 300 millimeter lens without guiding, but I want to be able to push. Yeah,
That's pretty good.
it's on a 300 millimeter lens, so it's about what I would expect.
Yeah.
But I want to try to push that up to like 4.5 minutes to be able to pull out more of the galaxies.
Okay, so you have to do some guiding.
Yeah. But I mean, even then, as long as my guiding doesn't have to be perfect, because I'm shooting at such a wider field of view, I just need to have something.
You don't need your off-axis guider for that. Your clock drive should work well enough to hold it for 4.5 minutes.
Nope.
For a 300 millimeter.
Nope.
No? Ooh.
When it does, when I've looked at it, because it's when I've been doing some of the processing, it's skewing the stars just enough that it futzes with the stacking software. So you start getting at around I can do 3 minutes, but at 3 minutes I start having a lot of frame loss, and then the stars start becoming a little bit more oval, and then the stacking software says like, I don't like this, and then I start getting a lot of rejects, and then the pictures go a little bit fuzzy. So 2 minutes is about the portion where I get really good quality. Probably up to 2.5 minutes, I'll be trying that next. But at 3 minutes, which is what I was shooting at, I start getting a lot of frame loss.
I'm surprised. Good night, Kay.
Night.
I'm kind of surprised by that, Connor, because the 300 millimeter is not a lot of magnification. That's like looking through a pair of binoculars. And I would have thought that your clock drive on your telescope could hold it reasonably well for that kind of magnification. Because I know mine does. I can take like binocular type pictures 5-6 minutes with a just mounted piggyback on my main telescope without me guiding it. The clock drive just holds it well enough for that amount of time. Now, when I'm looking through the telescope, I can only look, if I don't guide it, I'm only able to track for maybe 45 seconds before it gets outside of the illuminated reticle circle in the middle. And that would, that makes the star images not round anymore. But with just a telephoto lens, I'm kind of surprised.
Like I can do 3 minutes easily, but after that, then I start noticing degradation. And then when I was doing some experimenting.
Is your telescope a how's it mounted? Is it equatorial mounted, or is it an
equatorial?
It is. Mm-hmm. You got it lined up real well.
Should. You can only. I mean, there's only so much I can do with my alignment. The Celestron All-Star polar aligned does a fairly good job at getting a polar alignment, but even then, there's still. I think there's something with like the motor or the weight distribution on my scope that's causing the skew.
Okay.
But like, for example, So like,
You might also have to adjust. Can you adjust the speed of the drive? Can you slow it down and speed it up? Because I'd be willing to do that, because I know my clock drive is this way. If you look at the gear ratios and everything, my clock drive is set to do one 360-degree rotation in 24 hours, which is not correct. I actually have to I actually have to speed my motors up in order to get it to track at sidereal rate.
yeah, I'd have to go look at my manual to see how to do that. I know that Dean at Starzona was helping me out because I was having some an issue with it tracking. So this was the Heart Nebula. This was 2-minute exposures. I didn't do a lot here. But the 3-minute exposure of this, no, this isn't 3-minute exposure, sorry. But you can kind of see in here out towards the edge, there's a little bit of elongation within some of the stars.
Well, is that out on the edges? Is that just coma?
Well, this is cropped a little bit.
Okay.
This isn't the full frame, but it is towards the edges, but it's not through the scope itself.
Yeah, but I
there's
noticed
some
that
stuff.
in the middle, the stars look very pinpoint.
Yeah, but
It's
if you
only
zoom
the
in,
corners where
if you
I'm
zoom in on
seeing-
them, you start seeing a little bit of an elongation in the stars.
Okay, but
But
it's very noticeable in the corners.
Like here's maybe a slightly more prominent example. This
You
was
know,
also
and the
3-minute
elongate-
exposures. The
That
rosette.
looks, I mean, I'm seeing,
And you can see like over here in the top left quadrant, just
okay.
above the
I don't have
rosette.
the rosette nebula up. I don't see the rosette yet.
Oh.
That's taking a long time to come in.
Yeah, your internet's always been weird.
But I mean, I'm looking at this one picture of the Heart Nebula, and in the corners, I'm seeing that elongation very noticeable, and it's always pointed towards the center of the frame. That's chroma. I'm seeing that at all 4 corners.
But has the rosette loaded for you yet?
No,
Yeah.
it hasn't. That's okay.
But when I've done enough of it, you just start getting pictures where they just stop wanting to stack well. They start getting a lot of errors. Even if you look at the images, they look mostly fine when you're at the computer, but then the stacking stuff goes like, these are starting to get really funky. And it's like, that's why I loaded my exposures.
Huh. Okay. I believe you. I'm just, like I said, I'm just mildly surprised that you would see that happening with just a 300 millimeter. I'm just mildly surprised that you would have that kind of a problem.
Well, it's getting 8 o'clock.
Yeah.
I'm getting tired and it's been a long day. So thanks for
Time
joining,
me to
everyone.
go. I'll see you next month.
Good
night.
Anyone want to volunteer for a presentation or a main topic for next month? I'm kind of running out of a backlog and stuff.
I'll see if I can think of something, Connor. Maybe I'll come up with something for a main presentation. If not, I might volunteer for a constellation. Okay?
Sounds good. You could always use more presenters. Grad school is going to kick my butt this semester, so we'll see.
I'll let you know within a week or two. That way you have time to recruit someone else. If I decide I can't do a main and I do a constellation, that gives you time to find a main. Otherwise, like I said, if I do find something good for a main talk, then you have time to find someone for a constellation.
Thanks, Doug.
All right. All right. Good night, everybody.